When you dissolve an ionic compound in water, you sometimes generate acidity or basicity in the solution. We're going to talk about the acidity of salt solutions in this video. Our learning goals are to determine those acid or base properties of a salt. To remind you, a salt is basically an ionic compound that is the result of an acid and base neutralization reaction. So it's produced along with water when an acid and base react with one another. So what we're going to consider first is the combination of a strong acid with a strong base to make salt and water. Now I should mention that the salt is an electrolyte, and the cation is one that we might expect to have acidic properties because it would be like the conjugate acid of a base. The anion, or the negative ion, would be like the conjugate base of an acid. So we want to test those things to see what their possible reactions are in water. So we're looking for these kinds of reactions. We're looking for the cation to react as in the first reaction to generate a Ka that would make the solution slightly acidic. We're looking for the anion perhaps to react as in the second reaction that might create a solution that is slightly basic. So let's consider a particular example. In this case, we're going to mix perchloric acid with lithium hydroxide. These are both strong. The perchloric acid is a very strong acid, and the lithium hydroxide is a strong base. So when we bring these together, what we want to do is test the lithium ion to see if it reacts like an acid. So in other words, does it fulfill that first reaction? Lithium ion plus 2 waters goes to lithium hydroxide and hydronium ion. Okay, for that to be meaningful, the equilibrium constant would need to be greater than the Kw for water, because then it would be producing more of the hydronium ions in solution than water actually does. Well, it turns out when we test this against the Kb for lithium hydroxide, it has a Ka that is much smaller, certainly smaller than the Kw value, so we would not expect this to generate much in the way of acidic activity in the solution. The perchlorate ion would possibly be reacting with water as shown in the second reaction to produce perchloric acid and hydroxide ion. But for that to be the case, then the Kb value for the perchlorate ion, which would be given by Kw divided by the Ka of perchloric acid, would have to be something appreciable bigger than the Kw value itself. It's not in this case, it's about 10 to the minus 22. So we conclude that this reaction isn't happening to any great extent either. As a result, we would say that this forms a neutral salt. The salt is produced by a strong acid and a strong base, does not have any acid-base properties. Let's take a look at a different one. Let's look at weak acid neutralization, but a weak acid with a strong base to produce salt and water. All right, so this is the sort of reaction that we're talking about. Now in this case, HA is a weak acid, and MOH is a strong base. So we're probably going to see, as we did before, that the strong base does not have any effect on acidity. Just as the lithium ion did not have a strong effect on acidity, this will not either. The conjugate base of the weak acid, however, may have some effect because we have this reaction to think about, that when A- reacts as the conjugate base with water and forms undissociated weak acid with hydroxide ion, we already know that we can calculate the Kb for that as equal to Kw divided by the Ka of the weak acid. And since the Ka of the weak acid is less than 1, we know that that value will be greater than the Kw for water. So this will have a measurable effect on the acidity of the solution. As an example, in nicotinic acid shown here, we would calculate that the Kb value of its conjugate base is 5.6 times 10 to the minus 10. So indeed, this is greater than the Kw of water. And it allows us to draw the conclusion that basic salts are ones that are produced by a weak acid and a strong base. They would actually cause the solution to be slightly basic. We can also check out the thing that happens when a weak base is neutralized by a strong acid. So again, much of our mechanics is going to be the same. Here is the reaction that we're talking about, but in this case, HX represents a strong acid, so it could be hydrochloric acid or nitric acid. And a weak base might be something like an organic amine, as drawn here, and the result would be to produce the protonated amine and the A-, protonated amine showing here. Now, once again, we would expect that the strong acid does not have any effect on basicity, and the reason for that is that the product over there, HX, we know dissociates strongly, so this reaction lies strongly to the left side, so we're not actually adding much in the way of hydroxide ion to the solution. The conjugate acid of a weak base, however, does have an appreciable dissociation that produces hydronium ions in solution. We can equate the Ka for that protonated base by Kw divided by Kb of the base, and again that will be greater than 10 to the minus 14. An example of this would be perhaps ethanolamine, which is an organic amine. So in this case, we're producing an acidic salt. A salt that's produced by a strong acid and a weak base creates a solution that is very slightly acidic. So we can begin to draw some conclusions from these few examples. If we mix a strong acid and a strong base together, we get a neutral salt, no change in the acidity. When we mix a weak acid with a strong base, we'll get a basic salt, and that base comes from the fact that the weak acid has a conjugate base. So the conjugate base acts as a base in the solution. When we mix a strong acid and a weak base, the weak base has a conjugate acid that is a weak acid, so we would get a slightly acidic effect in the solution. Now, I'll remind you that strong acids include these, and strong bases include all of these. So as long as you can recognize strong acids and strong bases, you should be able to identify if a particular combination coming from a neutralization reaction would be one of the three events shown above. So the general steps that you would need to take when you want to determine the acidity of a salt solution is first identify the acid-base reaction that would produce the salt. To do this, you would take the cation of the salt and mix and put that together with hydroxide. That would form the base, and take the anion of the salt and combine that with H plus ions, and that would create the acid. Then you determine whether that acid base are weak or strong, and determine which of the three areas that falls into. You would then use this summary to predict whether it's an acidic salt or not.